Hello everyone, this is Amita from AIDS department. Now we are going to see about code conversion. Objective: the design and implement 4-bit binary to gray code conversion, gray to binary code converter. First, binary to gray code converter. The MSB of the gray code will be exactly equal to first bit of the given binary number. Now the second bit of the code will exclusive OR of the first and the second bit of the given binary number, such that if both the bits are same and the result will be 0, and if they are different the results will be 1. The third bit of binary code, gray code, will be equal to exclusive of the second and third bit of the given binary number. Thus, binary to gray code conversion goes on. Input and output variable. Input variable are B3, B2, B1 and B0, B0. Output variable G3, G2, G1 and G0. This is the truth table for binary to gray code converter. This is the Boolean expressions. This is the circuit diagram. And next, gray to binary code converter. The MSB of the binary number will be equal to the MSB of the gray code converter. Now, if the second gray bit is 0, the second binary bit will be same as the previous or the first bit. If the gray bit is 1, the second binary bit will alter. If it was 1, and it will be 0, and if it was 0, it will be 1. This step is continued for all the bits to do gray code to binary conversion. Input and output variable. Output variables are G3, G2, D1, G0. Output variables are B3, B2, B1 and B0. This is the truth table for gray to binary code converter. This is the Boolean expression for binary to gray code converter. This is the circuit diagram. Now this is binary to gray converter. Place 3 XOR gates, 4 bulbs as output, and place 4 switches, Now let's start connecting. Connect the first switch to the output bulb 1 and second switch to the XOR gate, and first switch to the XOR gate and the second switch to the XOR gate, and second switch to the second XOR gate, and third switch to the second XOR gate, and third switch to the third XOR gate, and fourth switch to the third XOR gate, and the output of first XOR gate to the second bulb, and output of second to the third bulb, and output of third XOR gate to fourth bulb. Now if we on the first Now if we on the fourth switch, the output will be 1, 0 0 0, and if we on the third switch the output would be 1 1 0 0, and if we on both the third and fourth switch the output will be 1 0 0 0, and if we on the third second switch and the fourth switch the output will be 1 1 1 0, and if you on the second switch and third switch the output will be 0 1 0 1. If we on the second switch, third switch and fourth switch the output will be 0 1 0 0. If we on the first switch the output would be 1 1 0 0, and if you on the fourth switch and first switch the output would be 0. Now it is gray to binary converter. Place one XOR gate, place 3 XOR gates, and 2 bulbs, sorry, 4 bulbs for output, and place 4 switches. We've placed 4 switches. Let's start connecting the first switch to the first XOR gate, and second switch to the first XOR gate, and the third switch to the second XOR gate, and the output of first XOR gate to the second XOR gate, and the fourth switch and output of the second XOR gate to the third XOR gate, and connecting the fourth switch to the XOR gate, and connecting the first output of first switch to the first output, and output of first XOR gate to the second output, and output of third XOR gate to the third output, and output of third XOR gate to the fourth output. If we switch on first switch, if we switch on the fourth switch, the output would be 0 0 0 1, and if we switch on the third and fourth switch the output would be 0 0 1 1. If we switch on the second and third switch the output would be 0 1 0 0. If we switch on the first and third switch the output would be 1 0 1 0. If we switch on the third switch the output would be 0 0 1 1. If we switch on the fourth switch and second switch the output would be 1 1 0 0. If we switch on the second switch the output would be 0 1 1 1. If we switch on the first and second switch the output would be 1 0 0 0. If we switch on the first, second and third switch the output would be 1 0 1 1. If we switch on the 4 switches the output would be 1 0 1 0. If we switch on first 3 and 4 switch the output would be 1 1 0 1. If we switch on first and third switch the output would be 1 1 1 1. If we switch on first switch the output would be 1 1 1 1. If we switch on first and third third, fourth switch, the output would be 1. That's it. According to the truth table, we can check the outputs.